Hello everybody, this is Coach Ronzo here. In this video, what I'm going to go ahead and cover is the surface area of cylinders, cones, and spheres too. So you have a variety of different things to go and work with for today. So surface area is what the primary part that we want to work with. Now, one thing about this one that you want to go ahead and understand is that pi will come into play, and also you have the following, how do you say? You have the following legend to go ahead and use. So make sure you're aware of some of the things that we're looking at, some of the new parts, especially like for like radius and looking at radius. Make sure for like the base and the side are usually new, and then not new, but like you always seen it before, and as well as total surface area, and then like volume will be hit a little bit later on. So this is what we have so far. Now, for the cylinder and cone, what we need to go ahead and understand is that for the lateral surface area, for the cylinder, we want to go ahead and use like a shower curtain example. And the lateral surface area is, imagine if you're like standing here, whatever it is, and then this happens to go and be a curtain. It's around, right? So I want to go ahead and emphasize the curtain in this situation because this is the lateral surface area for this cylinder. So obviously, if the whole cylinder here would have been lateral area that you need to go in and see, which is the white part here. Now, that being said, the height is actually the height of all the way to the very top where it's going to be meeting with the ceiling. So that's going to be lateral surface area. So the surface area is initially what it incorporates here. And then the very bottom down here, what they're standing on. So that would be considered the the surface area of a cylinder. Okay. So a few things to go ahead and consider as we're going here. Okay. Okay, so for the cone, we're using for the lateral, which is going to be the surface of this ice cream cone. So so everything that's around here is going to be a total surface, a total lateral will be the lateral surface area of it. Now, that being said, sometimes a cone does not have the little ice cream on it, right? So whatever the cone has that you have in your hand, that's going to be the lateral surface area. So everything that's around the cone. Now, for surface area, it's going to be including whatever the area of the ice cream is. So, which is going to be the ice cream at the very top. So, whatever you have here, where it meets and covers this part up. So, this little part, use a different color, use a green. So, wherever this part is right here that gets covered up by the ice cream, it's right here. Okay. So whenever you finish eating your ice cream, eating it, and then it becomes a flat surface, that's initially what a cone looks like. Okay, except this one looks a little bit more delicious. Now, that being said, if we're looking for the surface area of a sphere, what you're going to go and do is you're going to think of a ball, and you can think of like a sports ball. So like anything that deals with a close this. So anything that deals with the outside layer of the ball, so whether it's going to be like made out of rubber, whatever it is, or made out of like leather, whatever it is, or pigskin. So that's initially the surface area of it. Now, in this case here, you have like metal, and metal just covering the whole entire ball, and it forms it. So that's going to be the surface area of the whole entire sphere. There's no lateral, it's just total surface area of it. Okay, so whatever you need is to go ahead and cover it. Now, we're going to use these concepts for the next few problems that we have. Now, let's say we go cylinders. Okay, now for cylinder, what needs to go and happen, you have to find the radius and find the lateral and total surface area of each cylinder. So I'm going to do one by one. No, not one by one, but I'll do one cylinder, one cone, one sphere. For the radius, we have 4 right here, so that's 4 centimeters. And then you have 12 is going to be considered the height. So this is 12 right here. Now, that being said, the lateral surface area, if you go back to the equation over here, with the formula, L is 2 pi RH. So we want to go ahead and use that. So this is 2. Oh. 2 pi RH. So we're going to go and plug in what we know. So 2 pi, and then R is 4 times 12, which is H. So that's what we have here. So 4 times 12 is 48. 48 times 2 gives you 96. So this is 96 pi. It says to express it in terms of pi, so just leave pi there at the very end. 96 pi. And don't forget about the units, so it's centimeters in this case. Okay. Now, from here, the other part is that we're going to go ahead and add whatever we have. So I'm going to use a different color. So it's going to be L plus 2B. Now, here's the thing. You have to look for the B is a base. But the base of what shape is the question. So area of the base. So if I try looking for this, I'm going to look for my base, which is going to go and become this circle, because the base of the cylinder is circle. Okay, it's down here. So this one here is what I'm going to be looking for. So it happens to be 4. So that happens to be 4 there. And so how do you find the area of a circle? So area is pi r squared, which is pi 4 squared, which is 16 pi. And that'll be the area of what you have, okay? Now we're gonna use what we know. Okay, so 16 pi. So we're gonna plug in everything. So L is gonna be 96 pi plus let's see, 2 times 16 pi. So if we go and do this, we get 96 pi plus 32 pi, and then you just add them up at the very end. So you'll have 8, and then 3 plus 9 gives you 12. So that's going to be your S in this case. So 128 centimeters squared. So 128 centimeters squared. Oh, I forgot the pi. So 128 pi centimeters squared. I forgot this little square right here too, guys. So that's how you go and find the area of a cylinder. So that's one example. If you have any other questions, then I'm pretty sure that you can go and check out other videos too. Oh, the cone. Right, so the cone, what needs to go and happen is you're going to look for the radius. And in this case, for the cone, you're going to look for the circle again. So that means that my radius is worth 5 feet. So 5 feet, because it's given. Now the L is going to be slant height. So my slant height here happens to be 13 feet. Now, if you may notice, this problem here and in here is initially Pythagorean theorem. So if you notice, here doesn't have a slant height. So you have to use Pythagorean theorem in order to go and solve it. So down here, you will use a squared plus b squared equals c squared. And then you put in your parts that you need to go and find, and then you go in and find where how to go and solve for x. But in this case, for number 6, it gave us what its slant height was. So remember, you got to use Pythagorean theorem to find slant height. Okay, that's the biggest key thing. Now, so in this case, you have 13 for your slant height, and now your L happens to go ahead and be, let's go back to our formula chart. It's pi RL. So pi RL. So I'm going to go ahead and use pi RL. So it'll be pi times 5 times 13, which is going to come out to go ahead and be 65 pi. So 65 pi feet squared. Now, initially that's what we have for this part. So because you found out what the area it takes to go ahead and cover this cone around, not the bottom, but around what's around of the cone. So my S is a different color. My S is going to be considered to go ahead and be the L plus 2 pi r. No, actually, no, L plus pi r squared by fault. So it'll be considered L plus pi r squared. And L is already 65 pi because we just found out. And then now the other part is pi, and then r is going to be 5 squared. And so that means that it's going to be 65 pi plus 5 squared is 25 pi. And so 65 plus 25 gives you 90 pi. And so that's going to be your total surface area for this one. So it'll be 90 pi feet squared. The biggest thing is that, and the biggest problem that I can see from these is that maybe like if you can go ahead and help and use the slant height to go ahead and find it. So to find slant height, use Pythagorean theorem. So that's the biggest thing that you need to go ahead and look at towards too. Okay. So there you go. And sometimes you got to work backwards. Just plug in the equation and then work backwards to in terms of it. Okay. Okay. So actually, let me just go ahead and just do one example of this. So the lateral surface area of surface area is equal to 93 pi. In this case, my slant height was 6. What's my radius of this cone? So it said cone. So I'm going to use the same formula that I had. So it gave me the lateral. So that's not going to be S, it's going to be the capital L. So that means it's pi RL. So L is equal to pi RL. So if I know this is 93 pi, and I have pi, and I have my radius, I don't know what it is, and then I have L, which is 6, all we're doing now is just limiting what we know. So if I go ahead and zoom a little bit, eliminate the pi's, you get 93 is equal to R times 6, divide by 6. And so R is equal to whatever that value becomes. So it might be like 30, maybe like 30 or something. I don't know. I don't know, guys. We'll find out what it is. Okay, 93 divided by 6, 15.5. Okay, that's halfway through it. Twice more, over. So 15.5. So this one right here will be 15.5 inches. Okay, so that's pretty much it. So work backwards, okay? All right, last one. Sphere. Sphere 1. So if we're looking for sphere, you gotta understand the radius, right? So total surface area of the sphere. So radius is 14. So it's 14 meters. And now for surface area, if we got it here, we go back, it says 4 pi r squared. So that means this will be 4 pi r squared. And so that'll be 4 pi 14 squared